Hey there, everybody. Welcome back. This is 13.5 in Calculus 3. This is on the chain rule for multivariable functions. This is in Anton's 11th edition, fall of 2022, College of Sequoias. Let's just jump right into it. Recall in the last section, we were talking about the delta z or delta f effectively is the partial derivative with respect to each thing, dz dx times delta x and dz dy times delta y. I had fx like that and fy like that. I'm trying to switch back and forth between them so you get used to seeing different kinds. But what if x and y are functions of time, or t? And that means z is a function of time too. How does this upgrade? Well, we don't want delta x and delta y anymore. So we're going to have delta z over delta t. We've got dz, or partial of z with respect to x, times delta x over delta t, plus partial of z with respect to y, times delta y over delta t. We're going to find the limit as t goes to 0. And that gives us our values for dz dt. The total derivative right there, dz dt, is the partial derivative of z with respect to x times dx dt, plus the partial derivative of z with respect to y times dy dt. So it's a chain rule. What we have is z is a function of x of t and y of t. So we need to do the derivative and then do the inside derivative. We can scale this up to w being a function of x, y, and z. And then just adds in a third component. Delta w times dz times dz dt. So let's take a look at an example. Z equals x times y cubed plus 2x cubed times y. X equals cosine t, y equals sine t. We're going to find dz dt at t equals 0. Okay. Sorry, I had to clear my throat. We have z equals xy cubed plus 2x cubed y. X equals cosine t, y equals sine t. We're going to find dz dt evaluated at t equals 0. dz dt is called the total derivative. I'll make a note of that right here. These are called total derivatives, whereas the individual components are the partial derivatives. So we can see if we evaluate it t equals 0, x is 1, and y at 0 is 0. Our total derivative dz dt is partial of z with respect to x times dx dt, plus the partial of z with respect to y times dy dt. Let's just figure out what those are. dz dx are the partial of z with respect to x is y cubed plus 6x squared y. And then our dx dt is negative sine t. And then y, we do dz, partial of z with respect to y. We've got 3xy squared plus 2x cubed. Then the derivative of y with respect to t is just cosine t. And then we're going to evaluate these at t equals 0. So what do we have? What? Y is 0 and x is 1 here. So we're plugging those in. 0 plus 6 times 1 times 0 times negative sine of 0. Again, x is 1, y is 0. 3 times 1 times 0 squared plus 2 times 1 cubed times cosine of 0. So we're plugging all the things that we have in. The total derivative of z with respect to t at t equals 0 is 2. Okay. Another example. Let's kick it up a notch. We're going to have w as a function of x, y, and z. W is x to the 4th power times y cubed plus 2x times z squared plus 3y times z cubed. And we want to find the total derivative of w with respect to t when t equals 1. We are going to parameterize x, y, and z as x equals t, y equals t squared, and z equals t cubed. You should pause your video and try to give it a try. See if you can come up with what I got right here. Just take the partial derivative of each of these with respect to the individual components. I recommend writing them out. Don't substitute anything in yet. Show what the derivatives of dx, dy, dz are with respect to t, and then evaluate at t equals 1. Okay. So I've got with the partial of w with respect to x is 4x cubed y cubed 2z squared. And then I plugged in dx dt because it's 1. Well, I'm sorry, I didn't plug in. Dx dt, the derivative of dx or x with respect to t is 1. Sorry. Then I have my partial of w with respect to y is 3x to the 4th y squared plus 3z cubed. Our dy dt, t squared goes down to 2t. And we have the partial of w with respect to z. That component goes away. I've got 4xz. Bring the 3 down. I've got 9yz squared. And the derivative of t cubed is 3t squared. And we will plug stuff in. Evaluating at t equals 1, we've got literally just taking x is 1, y is 1, z is 1, and t is 1, and replacing everything in here with those ones. When you calculate the total derivative of w with respect to t, you're going to get 57. That's it for the first part of the chain rule. It's pretty easy. Peace.